Welcome back today on our lectures. Today we are going to do probability and statistics, and our question is find the MGF or the moment generating function of a normal distribution and hence use it to find mean and variance. So our first step, whatever we know that the CDF of a normal distribution is given by 1 over parameter sigma 2 pi multiplied by e negative a half into x minus mu over sigma and squared. So when we want to find the MGF, we know that MGF is given by expectation of ETX, expectation of ETX. So we know very well that whenever now we want to find the MGF will be given by the integration from negative infinity to infinity of e raised to ETX multiplied by 1 over sigma 2 pi multiplied by e negative a half x minus mu over sigma, and this time it is squared. Because this is our constant, it will come to the other side. So we will have 1 over sigma 2 pi and its square root the integration from negative infinity to infinity of ETX multiplied by e negative a half x minus mu over sigma squared. So we are going to let x minus mu over sigma to be y, such that we have our sigma y to be x minus mu, so that the sigma dy is given by dx. Sigma dy is given by dx. Sigma dy is given. So we want to replace dy with dx up here. So we will have 1 over sigma 2 pi integration from negative infinity to infinity of ETX multiplied by e negative a half y squared multiplied by sigma dy. So sigma will come because it is a constant, so it will cross the other side and it will go the other side, so that we are going to have 1 over 2 pi, because sigma cancels, negative infinity to infinity of ETX multiplied by e negative a half y squared dy. E negative a half squared dy. So we are going to have 1 over, because our x now is sigma y minus mu, so it will be 1 over 2 pi from negative infinity to infinity of e t, and our x is now going to be sigma y plus mu times e negative a half y squared dy. So at this particular point we are going to open this bracket, so that we have this times this, and e to t to this is a constant, so it will come outside. So we have 1 over 2 pi the square root times that constant, which is e t mu. E t mu is a constant, it will cross the other side. E t mu times this one, when you open that bracket, it will be e t sigma y, but it is integration from negative infinity to infinity times e negative a half y squared dy. So because we are multiplying, we are going to add the powers, so that I have that one multiplied by e t mu integral from negative infinity to infinity of e, is a common. I'll factorize out negative y, so it will be negative y into y squared, then minus 2 t sigma y. So and it is with respect to dy. By the process of completing square method, we will solve this one out, such that I'll have now 1 over 2 pi multiplied by e t mu integral from negative infinity to infinity of e negative a half into y squared minus 2t sigma y plus t squared sigma squared minus t squared sigma squared. So by this I'll have completed the square, because I've introduced it and I'll also cancelled it. So I'll have, by factorizing that, I'll have negative infinity to infinity of y squared not y squared but y minus t sigma, but this time round it is squared and it is raised to squared and it is raised to e negative a half times e raised to, when I open this bracket, I'll have e, so this one and this one multiply and it will become positive t squared sigma squared over 2, t squared sigma squared over 2, and it is multiplied by 1 over 2 pi times e t mu. So I'll set this one to be my u. So I'll say that I'll come and say that u is equals to, y minus t sigma, such that my du is equals to dy. My du is equals to dy because those are constants. So whenever I'll replace it, I'll have 1 over 2 pi the square root times e t mu, the integral from negative infinity to infinity, of e negative 1 into, because I've let it to be u and it is squared, times e t sigma y, they are both squared, over 2, and this is with respect to dy. This is with respect to dy. So I'll have, because this one also is a constant, it will come outside the integral sign. So I'll have 1 over 2 pi multiplied by et mu multiplied by et squared sigma squared over 2, the integral from negative infinity to infinity of e negative a half u squared. So this one, whenever we have this one, the result with respect to dy, whenever we integrate this one with respect to dy, the answer will always become 2 pi, and that is the square root. So what I'll have will be 1 over 2 pi multiplied by et mu multiplied by et squared sigma squared, and this is over 2 times 2 pi the square root. So this one will cancel out, so that I'll factorize out e because they're being multiplied, t mu plus t squared sigma squared over 2. So we are going to use this one now as our moment generating function to find mean and variance in our next video. Thank you.